Hello students, let's discuss about acceleration today. What is acceleration? This is a term you may be familiar with, right? Suppose if somebody is learning driving, they'll be asked to press the accelerator, accelerate the vehicle. Or whenever there is an increase in speed, you may have heard this term acceleration, right? So in our previous classes, we have introduced terms like speed and velocity. What was velocity? It was the rate of change of position, right? So to define the rate of change of position, we have introduced the term velocity. Here, to introduce the rate of change of velocity, we are introducing a new term, that is acceleration. So whenever the velocity changes, we have acceleration. But if the velocity is not changing, there won't be any acceleration. It will not be an accelerated motion. But why I am specifying velocity? Why I am not saying speed? Because acceleration is a vector quantity just like velocity. So to define acceleration, I need to consider both the magnitude as well as direction. So what is acceleration? It is the rate of change of velocity. Rate of change of velocity. I represent acceleration by a letter, small letter a. So it is the change in velocity upon time. I said it's a vector quantity. Suppose an object, when you observed the motion, it was moving at a speed u. U was the initial, I'm using the term velocity to be more specific here, initial velocity, and v was the final velocity of the object after a time duration of t seconds, right? After time t seconds, when I was observing the object, what was the final velocity? It was v. Then what will be the acceleration then? The acceleration will be change in velocity, right? So final velocity minus initial velocity upon time, right? So this will be the equation for acceleration. It is the rate of change of velocity. Then what will be the SI unit of acceleration? Acceleration means change in velocity. So here the unit will be, velocity's unit I know, it is meter per second, and SI unit of time is second. So what will be the SI unit of acceleration? Meter per second square, right? This will come to the denominator. This second will come to the denominator. So it will be meter per second square, right? Now, so if I am saying an object is moving along a straight line at a constant speed of 50 kilometer per hour, is there any acceleration involved in it? Is the object accelerating? If I am saying an object is moving at a speed of 50 kilometer per hour along a straight line, what will be the acceleration? Will acceleration be involved in this case? No, because it is moving along a straight line at a constant speed. There is no change in speed. And the direction is also same. So here the acceleration will be 0. Why I am specifying the direction? Because I'll give you another example, then you will understand why I am specifying the direction. Because it's a vector quantity, so I have to consider here the speed was not changing and the direction is also the same. So acceleration is not involved in this case. But if I say another example, an object is moving at a constant speed, like 50 kilometer per hour, like this first, then it has changed the direction but the speed was same. Now, acceleration is involved in this case or not? Of course, even the speed is constant, the direction of the object is changing. So, this is an accelerated motion. As I have already told you, just like velocity, acceleration is a vector quantity. So, to define acceleration, you need to consider the magnitude as well as direction. So, here, even though the speed was constant, since there was change in the direction, it was an accelerated motion. Or I can give you another example. An object is moving along a circular path like this. It was moving at a constant speed of 10 km per hour. Now, so here if it is undergoing a circular path, don't you think that the direction is changing at every instant? So for example, if I am consider this point, the direction of motion of the object will be like this, tangent to that. At this point it will be like this, at this point it will be like this, at this point it will be like this. So even though it is having a constant speed, this is an accelerated motion, because here the direction is changing. So it is an accelerated motion, right? So I hope you must have understood acceleration, its SI unit, and what are the two important things involved in this, that is the magnitude as well as direction. Now give you an example how to calculate the acceleration of a body. For example, an object, it was at rest initially, and it started moving, and after 5 seconds its velocity was 10 meter per second. So initially the object was at rest. So what will be my initial velocity? Initially it was at rest, so I can write the initial velocity as 0. And what is my final velocity? This is 10. And the change in velocity happened in a time duration of 5 seconds. So what will be my acceleration? It is v minus u upon t, or change in velocity upon time. So it will be 10 minus 0 upon 5, right? So it is 2 meter per second square. This will be the acceleration of the object. Now, here we were discussing about the increase in the speed. What if the speed is decreasing? For example, an object, when I was observing, the object was moving at a speed of 20 meter per second. After 10 seconds, the object stopped. So if the object is stopping, what will be the speed? It will be 0 meter per second. So the object came to rest after 10 seconds. It was moving at a speed of 20 meter per second. So here what will be the initial velocity? This will be u, and this will be the final velocity, and this will be the time, right? So what will be the acceleration here? It will be same formula, v minus u upon t, but here you will see a negative answer because your object was coming to rest. So it is 0 minus 20 upon 10. It is minus 2 meter per second square. So here the acceleration has got a negative value. So when the speed is decreasing, you will be getting a negative acceleration. It is called deceleration or retardation. What it is called? Deceleration or retardation. Thank you.